slope vector or direction fields are graphical representations of differential equations. Okay, so, you saw a little bit of this last week. And it was kind of leading us into it. And when you said, what are all those crazy marks? Okay, this is a slope field. And as we kind of talked about, each of those marks represent what the direction of the graph is going at that point. Okay, it represents the slope. So thus, these are graphical representations of differential equations. That's why they're falling right here. You can use slope fields to visualize the parallel curves that solve the family of solutions to a first-order differential equation without algebra. For example, the differential equation dy dx equals y has the property that the slope at any point is equal to the y-coordinate at that point. And so, we'll talk about these as we go, but dy dx equals y. This is saying the slope is equal to the y value. And so, what you're noticing here that each row is a value of y, right? When we have horizontal lines like this is y equals 0, this is y equals 1, y equals 2, so on and so forth. All of those slopes across the whole way, because there's just a y, represent the slope at that point. Okay, so like these right below 1 are the slope of about 1. Okay, the closer you get to 2, these slopes are about 2, so on and so forth. We can draw many line segments at each marked point showing the slope of the curve there. The slope field will show the general shape of all the solutions. In order to sketch a particular solution, you have to have an initial condition. Okay, if you have an initial condition, like right here, we can see these curves going along, can't we? If you have an initial condition, you know specifically, okay, it might have to go through this point. We know specifically where it goes. And we're getting ready to talk about that. Okay? Let's go into example 1. Excuse me. Sketch the slope field for dy dx equals 3x minus 2 using the table below. So, this you'll notice is based on an x value, right? Now, keep in mind, dy dx. dy dx is another name for the derivative, which also means it is another name for the slope. Okay? I mean, y prime, derivative, slope, it's all the same, right? So that's another point for the slope. And in this first one, each slope is going to be equal to 3 times the x value minus 2. So we're going to do some math, and then we will work on putting these in. So let's see, what x values do we have on this graph? So I really only need to talk about -2, -1, 0, 1, 2, don't I? Okay, so let's find dy dx of each of these, and we'll talk about the graph. So if we put in -2, 3 times -2 minus 2. Put in -1, 3 times -1 minus 2. 3 times 0 minus 2. 3 times 1 minus 2. 3 times 2 minus 2. Okay, I'm just plugging into the equation, right? So what this is saying, anytime, and there's only an x in this equation, right? If there's a y, we'd have to use x and y. But this is saying since there's only an x here, anytime the x value is -2, the slope is going to be -8. So as we go over here and we think about -2, like all of these points represent -2 when x is -2. What's the slope of -8 look like?
Almost as straight.
It's going to be very steep, yes. And since it's negative slope, it's decreasing. It's, I don't know, how do you guys, angled down to the right, angled up to the left? I don't know how you want it, So what I'm saying here is that it's going to be very steep. Each of these, now, I don't know that mine stayed all the same. Visualize that those are all very steep negative slopes, and they all are identically the same for tens, right? Okay. because that's when x is negative 2. What do we know when x is negative 5? Or, strike that. What do we know when x is negative 1? Slope is negative 5. So now think in relation. What do we know about negative 5 slope in relation to negative 8?
It's a little bit less.
Still pretty steep, but a little bit less steep. And still negative, yes? So now your goal is to make that look like that. Easier said than done, I know. What do we know when the x value is 0?
It's negative 2.
It's negative 2. So what's that mean in terms of slope? Less steep. Still negative, yes? I don't know if something like that. I maybe should have made them a little less. Can you kind of tell the mine are getting a little less steep each step of the way?
Mm-hmm.
It's hard, okay? What about when x is 1?
That's 1.
The slope is 1, so it's increasing. We're going the positive direction now, and 1 is that middle of the way direction, isn't it? It's not steep, it's not, what's the opposite of steep? I don't know, you know, it's that middle, it's that exactly, think like a perfect diagonal line, y equals x, right? So these if done correctly, should be the least steepest on the page right now. I feel like some of mine got a little too steep, though, to be honest, but I don't know.
It's hard when you're trying to read.
It is difficult. I liked my notes a lot better, but. And what about when x equals 2?
It's steep.
It's steep in the positive direction. So it should be steeper than what we just ended on, at least, right?
Wow. Looks like I just drew a bunch of lines on a page. Yeah.
You did just draw a bunch of lines on a page. I don't know what you're thinking you drew, but you just drew a bunch of lines on a page. Now, what shape do you see here?
Parabola.
Why do you say parabola?
Because it goes down and it'll go back up.
Okay. Do we see curves coming down and up? Okay. What would verify that we would expect a parabola?
Point.
If this is dy dx equals 3x minus 2, what would happen when you would integrate this?
Yes.
You would get an x squared, yes?
Yeah.
Okay. So that's kind of like, and I can show that real quick. If I multiply that dx over, right? And you've got dy equals 3x minus 2 times dx. Well, if I take that and integrate that, the integral of dy is y. The integral of 3x,
3 times x squared.
add 1 to the exponent and divide by a new exponent, right? Minus
2x
2x and then
plus
plus c. That's what this graph is. Now that plus c just indicates it's a family of curves. Okay? Like this is not just one parabola, it's parabolas stacked upon each other, so to speak, shifted up and down by some c value. Let's see, do I dare try and do this? You can, I always kind of have to think ahead. You can kind of try and sketch one in. And when you sketch one in, you're trying to well, I don't know. That's kind of my parabola. I was trying to sketch it in. It doesn't quite go with that one. But do you kind of see it following the slope? That's the idea of a particular solution there. Okay, so I'm going to put a comment here that slope fields, gosh, represent families of curves. Okay. In this case, yes, it was a parabola. And we know it was a parabola just by basic integration, and you can see that based on the shape too. Now, the other thing to point out, there was only an x here, right? There was no y, so we only needed x values in this one. I will say if only it could be that nice every time. Okay, we only needed x values because there's only an x in that differential equation. Okay? Okay, we have another slope field to sketch in number 2 when you're ready.
Can you add over? So separate the y's from the x's.
We can rearrange this a little bit to make it easier to plug into. Now, as we look at this problem, one of the big differences though, well, there are more boxes. There's more going on here. I don't need just x this time. There's x and y in my equation. So I'm going to need x and y pairs because the slope's not going to be the same at each. I'm not going to be able to say, oh, all the x's are this slope or all the y's are this slope. So there's more going on. Okay? In all honesty, you could even do this. All those boxes won't take care of everything. Okay? Now, one thing that would be easier to do, before we start plugging in, let's take the equation they gave us and solve for dy dx is what I would suggest. Okay? If we're going to solve for dy dx, how do you want to do that?
Subtract
Subtract 2x. And then divide by negative y.
2x over y equals 2x. I do it the way so you don't get any negatives.
Well, and either way,
You want to get
our answer is going to end up positive. So if you keep the negative y dy dx here, and it won't matter in this case. Oh my goodness. Sorry. Negative y dy dx, and then if I go this route, you subtract 2x, yes? Deal with my negatives. I know we don't like them, but I'm getting ready to get rid of them because then what do I do? To solve for dy dx, we're going to divide by negative y. Negative 2x divided by negative y is, are you guys okay with that? Now, if you went the other way, did you end up in the same spot? You did, okay? So, with that in mind, folks, this is what is going to be easiest to use to plug into. Okay? My suggestion, where do I want to start? I don't know where I want to start, honestly. Let's start with our first column here. Okay? Now, if we start with our first column, now keep in mind, not all columns are going to be the same. We're going to end up doing some of this in our head, or we're going to, double values, those type of things. But so, for instance, this point right here is negative 2, comma 2. Okay? What do we get at the ordered pair negative 2, 2 when we plug it into this equation here? Because it's negative 4 divided by 2, so we're going to have a slope of negative 2. Let's go ahead and plug in this whole row, and then I'll put them on there. Is that okay? This whole column, excuse me. So let's try negative 2, 1. So I'm looking at right here, yes? So negative 2, 1, what do we get? I'm with her, you guys? Negative 4? 2 times negative 2 is negative 4, divided by 1. Let's go ahead and plug in negative 2, 0. All of a sudden we get a dividing by 0. So it is a D and E. What about negative 2, negative 1? Positive 4. And negative 2, negative 2. Okay, you see a pattern there?
Yep.
Okay. Now, let's go ahead and put these slopes in. Okay, so up here at -2, -2, a slope of -2. Negative should technically be a little steeper than -1. I'm not sure if that's, I don't know. That kind of looks like -1 to me. I'm being too picky though, too. There's my -2. Then I have a slope of -4, so that's steeper. D and E. How do I draw D and E?
You don't.
Okay, you don't. There's no slope. Okay. That can mean a couple of different things, but yeah, you don't is a good answer. Now, -2, -1 had a +4 slope. So what's that going to mean? Yeah, it's going the other way. You know, if you can kind of mimic your steepness, but flip it the other way. And then slope of 2. So less steep, but in the positive manner. Whatever. Okay. And we're not, as I said, we're not going to plug in all of these, but I am going to plug in some. Let's go ahead and do the -1 row. Column, excuse me. And here's what I'm going to say. As you go through this, are you going to have to list out every point? Are you going to want to list out every point? No. I'm trying to get you guys some ideas, get you going. But you're also going to find some trends, some patterns, depending on the problem. So if we start with -1, +2. What do I get when I plug in -1, +2? -1, +1. I could save myself a box here. What about -1, 0? And so what's the generalization I can come up with?
There's an asymptote. Third way.
Okay. Well, and could be asymptote. I'm trying to think if it guarantees an asymptote. But anytime y is 0, there's a D and E, yes? So I'm not going to waste a box putting that in. -1, -1. And -1, -2. 1. Okay, well, let's plug these in. So -1, 2 has -1. Then we have a -2 slope. Where else did I have a -2 slope? That. Well. And then nothing. And then we have a +2 slope. Then we have a +1 slope. It seems like it should be easy. It's just a little like tick mark, but
I can't.
it's
How do I explain it?
there's some practice to be taken
I got
To-
precise, but
to get them relative to the others. Yes. Okay. Let's generalize this next row. I mean, I'll use 0, 2 as an option. What do you get when it's 0, 2?
0.
0. What's the generalization I can make here? That whole column, when x is 0,
So,
slope is 0 every time. What's a 0 slope look like?
horizontal.
I can draw this one, right? Now, so I'm going to put a horizontal piece at 2, at 1, at -1, and at -2. I'm not putting anything at 0, 0 because that was a D and E. You know, that's just a really weird thing now.
0 over 0 be
0 over 0, if you remember L'Hopital, is an
that's-
indeterminate form,
Yeah.
and it is just
That was a really
Nothing.
stupid question I just asked.
so. See, any other level, I can't say indeterminate form and then have any clue what I'm talking about. You guys, we've talked about that. So,
that doesn't mean
I'm going to blame that on the weekend.
okay, now
Bring back.
what happens when I put in the +1 column over here?
I bet it'll be the same.
We're going to have the -1s, but
The positive.
it's going to do, so like right here, this slope was
Negative 2.
+1, or excuse, This slope was -1. So what's it going to be over here? +1. And again, you don't trust yourself, plug them in, right? But we're just changing over here. There's still going to be the same y values. It's just changing the x values, so it's just going to change the sign. So I'm not filling out any more chart. I'm using my chart to go. Okay, so that becomes +1. This becomes +2. Down below, these now are going to be negative, right? So -2, -1. Next column, 2, 4, 4, 2. So now it's going to be +2, +4, so even steeper, -4, and -2.
Looks kind of like X or a parabola and a reflection.
So a parabola and a reflection. What is that?
Oh, it's on ellipse.
No.
No.
An ellipse would go in.
They were just doing it in pre-calc.
They were.
Hyperbola or what's your
Hyperbola.
I don't know.
hyperbola?
This is a hyperbola. Okay? It is where, now, and we don't know, I don't know if I want to argue if we know enough or not, but, it's a hyperbola where the pieces are going out. Okay? Kind of like, it looks kind of like two outward facing parabolas, but they're not really parabolas. They're slightly different shaped. That's why when you said a parabola and a reflection, I was like, that's kind of the
That's
idea.
because I didn't know what they were called, but I saw Emma's paper the other day because I was looking at them.
If we go and integrate this real quick, I don't know if I need to, but we're going to do it anyways because it's good practice. So if I use this 2x minus, what do I want to do here? I don't want it in this form, which is what threw me off, because I don't want to integrate that form. I need to get my y's and x's separate. So let's put...
Multiply y back over.
Or I was going to say, if we take this and multiply the dx over and make them positive. Or I guess you guys are saying multiply the dx over, multiply the y over. I'm with you now. My brain was having a moment. Sorry. So if we multiply the y over, it's y dy. If we multiply the dx over, it's... Oh my goodness. Are you there?
Mm-hmm.
You guys were there ahead of me. Okay. Integrate. Integral of y is...
Y squared.
Add 1 to the power, divide by a new power. Integral of 2x.
X.
Squared plus d.
Well, add 1 to the power, it's 2. Divide by the new power, 2 divided by 2 cancels, yes?
Yeah.
And then if we multiply the 2 over, right?
2x squared.
So y squared equals 2x squared plus c. Now, well, there's a couple different ways we can express it. Yes, we could square root it. Y equals plus or minus the square root of 2x squared plus c. That's not really a form that I don't know. I guess you can that's not exactly a normal form that we recognize. Another option, though, is if I use a variation of this and
Y squared minus 2x squared plus.
I was going to reverse it, but yeah. I have 2x squared minus y squared equals c. And again, it has to do with the c it's just an arbitrary value. Okay? But do you guys remember x squared minus y squared or y squared minus x squared? Those were the hyperbolas. X squared plus y squared over values were ellipses and circles. Put a subtraction sign in and it's hyperbolas, either going out or up and down. Okay? So.
I can kind of see our box too.
Oh, like if you to do the asymptotes?
Yeah.
Yeah. So. And I'm not going to try and draw that one. Okay. We're going to do some generalization on this next page, or at least on A, B, and C. Consider the following equation. We're using this equation, I think, for the whole page. dy dx equals negative x over y. First of all, compute dy dx at each set of points and then answer the following questions. So, if you plug 1, 1 in, what are you getting?
-1.
Okay. If we plug negative 1, 1 in,
1.
negative 1, negative 1,
-1.
1, negative 1.
1.
Are you guys with that?
Yeah.
Okay. dy dx is positive in quadrants blank, and dy dx is negative in quadrants blank.
2 and 4.
Yeah, positive and 2 and 4.
You know what? I'm not even reading that.
So let's review real quick. Quadrants
Oh,
1, 2, 3, 4 go along with all students take calculus, right? So what quadrant is 1, 1 in?
1,
Quadrant 1. Negative 1, 1.
2,
Negative 1, negative 1.
3.
And 1, negative 1. Are you guys with us now? Because that's the part that takes a moment, isn't it? Is assigning everybody. So dy dx is positive in quadrants
2 and 4.
2 and 4.
oh man. Well, we have those things from the unit circle on the AP exam.
What do you mean?
Like where we'll have to use like the also the same calculus.
Just with it comes up within problems.
Oh, okay.
I mean. Okay, and negative in quadrants.
1 and 3.
I threw in Roman numerals because quadrants tend to be expressed in Roman numerals. Not that I necessarily care, but
Did you do that on yours?
Yeah.
okay.
Do you see that? Remember the
Compute dy dx at each set. So if you recall from above, dy dx was
Negative x over y.
negative x over y, just writing it down from above. So at 1, 0, Deanie, I actually have undefined written in mine, but same idea, right? 2, 0,
Undefined.
negative 1, 0,
UND.
negative 2, 0.
UND.
Undefined, D&E, whatever. Okay.
I wrote
Write an equation that would describe the slope as undefined and then the slope as 0.
Or y over x was undefined. If it was y, x over y was undefined. If it was y over x, it'd be 0.
Yeah.
Okay? Except this isn't asking for a differential equation. It's asking for a regular, just like a, no dy dx is in there, just an equation.
Like y equals
Y equals an X.
x equals y.
But what does the line y equals x look like? Does it have a undefined slope or a 0 slope?
No, that would just be on.
Yeah, y equals x is that. It has a slope of 1. Not what I'm looking for, but that's an equation, if that's what you're trying to get at.
So then is it like y equals mx or something like that?
What if we just? What if we integrated that?
Waylon Gerald, please report to the high school office. Waylon Gerald, please report to the high school office.
We integrated the equation that goes with
It's
that.
not going to get you there.
That's
Not for what, no, not for what we need here. So okay, let's start with the slope of 0. What kind of lines have a slope of 0?
Horizontal.
Y
Horizontal.
equals 3.
Oh, so like y equals a number.
y-axis lines.
Yes.
Okay, so horizontal lines have slope of 0. Horizontal lines are y equals some number, yes?
So then that would be like y equals c.
Yeah, I think I have y equals a, but, it's the same idea.
Which one do you want to use?
Well, I feel like A and B are what they tend to use for that type of thing. I had to look and see if I had, here's the deal. You've got 26 different variables, really, and then some when we throw in things like alpha or whatever, so.
You have capital and
No, what I have is a headache.
lowercase.
Okay, so y equals a, or in other words, it is any horizontal line. Now, why I opted to do that one first, I don't know, but I did. It just seemed easier in my brain. I felt like you guys would get that one easier. What kind of lines have an undefined slope?
X equals A.
Vertical lines have undefined slope, and it's x equals a number. See, I just felt like you'd get the other one quicker. So it is x equal a, or in other words, any vertical line. Okay.
That's what my finger.
Are we getting there? Yeah. Again, we're going somewhere with this eventually, okay? We're just not there yet. Okay, consider these values. And so we are still using dy dx equals, what is it, negative x over y. Okay, so new set. 1, 1.
Negative 1.
2, 2.
Negative 1. Negative 1.
Or positive one.
Positive 1. No, it's negative
Still
1.
negative 1. Second guessing.
Negative 2, negative 2?
1.
Negative one.
Bye.
Okay. What equation would express dy dx equals negative 1?
Y equals negative x.
Okay, so this, it is kind of integrating here. But basically what equation is, think about it. What goes through 1, 1, 2, 2, negative 1, these same pieces. Now, if we want negative 1, it'd have to be y equals negative x.
Plus C.
If we want positive 1, we're going to say y equals x. I don't have a plus c on these. I mean, a plus c, well,
With the balance.
it could be there. I mean, it could be there. I don't think I have it on there. Guess I should double check. Yeah, I don't have it on there, so. If we were making this official and integrating all that, we'd talk the plus c part. Okay. Use the grid at right to sketch the slope fields for the values calculated for everything we've done on this page. Okay? We're going to draw the particular solution that passes through the point 0,2, and we're going to find the equation for that curve. AKA, we're going to finally integrate. Well, I think I integrate. Now, let's fill in some of these fun marks. If we go back up to A, 1, 1
Negative one.
is negative 1. Negative 1, 1, positive 1. Negative 1, negative 1, negative 1, 1, negative 1, positive 1. Did I get that right?
It's like binary, so.
Okay. That next chart was all undefined, yes?
Yeah.
The next chart was all undefined. And that was at what? 1, 0, 2, 0, negative 1. Which, okay, so undefined, we tend to not draw anything. But an undefined slope is a vertical slope. Now, for whatever reason, we don't usually, it's not like we don't usually do this. Okay, but that's kind of what's going to happen. Does that make sense? Okay, what's the other chart we have? 1, 1. Oh, wait, we already did that, didn't we?
1, 1, 2, 2. We didn't do 2,
Okay, 2, 2. There we go.
2.
It's 1. 2, 2 is negative 1. Negative 1, negative 1. Negative 1. Negative, oh, I already had that. Negative 2, negative 2. Negative 1. By extension, what else could you fill in at this exact moment?
Probably
2, -2.
Whoa, wait. Extend what we just had on this. Do you see this
Oh.
diagonal?
3, 3.
3, 3, and
-3, -3.
you guys run the next extension.
Yeah.
Okay. By other extension, what about, so 1, -1, and -1, 1 were positive 1 slopes. What else are we going to know?
2 negatives.
2, -2. Are you seeing where we're going with this? 3, -3. -2, 2. -3, 3. You're going to find patterns as you go about this, right? You're going to find things that work. Okay, we have a lovely X going right now. I have all of mine filled in, so I must have just gone back and just, kind of plugged them in. Remember, we're using negative x over y. So it's x over y opposite your signs, yes? So I'm right here. You go wherever you want, but 2, 1.
2.
That's going to be 2 over 1, but then -2, yes? So it's going to be a little steeper than what's around it. 3 over 1, but negative is going to be steeper yet. I'm up here now. 3 over 2, a little less steep than what I just did, negative. What are you noticing about this whole quadrant?
It's all negative.
It's all going to be negative, isn't it? Because it's only going to be a positive divided by a positive with a negative thrown on. Okay? 1, 2. 1 over 2 and negative. So now I've got a slope that is less than 1. Okay? 1, 3. Less than 1. And 2, 3. Less than 1. Are we seeing it?
It's like a circle.
Now,
I was just gonna say.
if I go down to quadrant 3 here, what's going to be true about quadrant 3?
It's
They're all
gonna
gonna be the
reflect
same.
They're all going to be the same positives, yes? Same idea. And it's x over y, so -2, -1, well, that's going to become a slope of -2, yes? So steeper. -3, -1, that's going to be a steeper slope yet. -3, -2, less steep. If I go over here and -1, -2, that's our least steep because that's 1/2. We've got 1/3 and 2/3. What's going to happen in your other quadrants?
Same thing, just reflected.
Same thing, but negatives, yes? Or positives, I mean. It'll be the negative of the negatives, which makes it positive. So, 2, 1, that's going to be +2. 3, 1, +3. 3, 2, that's 1.5. So a little less steep. Over here, 1, 2, so that's 1/2, my least steep. 1/3, 2/3. And 2, 1, steep. 3, 1, steeper. 3, 2, 1.5, less steep. 1/2, least steepness. 1/3, and 2/3.
It's looking like an optical.
Optical illusion. Okay, we did talk about the x-axis, right? No wait, which one did we talk about?
Why?
Yeah, the x-axis, because it was.
Yeah. 1, 0, 2, 0, 3, 0. Those are all going to be undefined. We never did talk about the y-axis. What's going to happen here?
Zeros.
0, 1. So that's going to be 0 over 1, 0, 2, 0, 3. These are all going to have a 0 slope, except don't include 0, 0. Special ugly case, all right? Okay. So, we just did part D. Use the grid at right to sketch the slope field for the values entered for A, B, and C. Draw the particular solution that passes through point 0, 2. So where's 0, 2?
The y-axis.
Okay. What are we drawing?
Circle.
Circle. If it's a circle, what should be true of this circle?
It should stay within the same.
Should it go through some other similar points?
Yeah.
If it's a circle,
0,
Which-
2, or 2, 0.
yeah. In other words, you're going to end up going through all your 2's, aren't you? Does that make sense? Okay. I can't do this. I have to, like, mine's not going to be a continuous circle because,
Mine looks like the moon.
okay, there you go.
Mine looks
Wow, yours looks really good.
Yours looks way better.
Forget the fact, but notice I couldn't just do a circle. I had to, like, sketch pieces together. Okay, what is the equation for this solution curve? Now, we can integrate, or you can tell me the equation for a circle with radius 2.
Y equals 2 pi.
X squared plus
I'm not asking about circumference.
Oh,
Equals r squared, so it'd be.
What'd you-
4
X
equals.
squared plus Y squared.
oh.
X squared plus y squared equals r squared is the equation for a circle that is centered at
0,
0, 0. So we could say x squared plus y squared equals 4. And if we integrated this thing, would we get this?
Yeah.
We'd have a plus c. Okay. We'd have the c instead of the value there. You could, if this was solved for y, it would be plus or minus the square root of 4 minus x squared. That would be valid too.
Oh my gosh. Is that like, that's like one of the questions on the test.
Yeah.
What? Huh?
That,
What test are we talking about here?
the test that we just, the test that was.
Yeah.
Okay.
No, it's kind of similar, but it's not, because it was integration, and so that's like a.
Hurry, let's do G and H.
Yeah, I just realized I was thinking, oh, next page is the matching, but never mind. It's G and H first, and then we'll match tomorrow. Forget it. You guys can match on your own tomorrow. Thank you guys. Okay. Explain what happens to the slope values as you move from left to right with a fixed y value. Okay, so slope values. As you move from left to right, if the y values, wait, which way did it say it?
Left
Use
to
a fixed
right.
y value.
As you move from left to right with a fixed y value.
Yeah.
Well, it kind of depends on your y value, actually, though. Because if your y value is positive, if your y value starts positive, then dy dx is going to,
Go from increase.
it's going to decrease is what's going to end up happening. I'm trying to think of the best way to explain this. Whereas if,
Is it like an inverse relationship?
Change.
Yeah.
Based on the positive y value.
well, I know, I'm trying to figure out how I want to explain this. If you are, okay, so as you move from left to right with a fixed y value. So if y is always the same here, so y being the same, for instance, I'm looking here at 3, okay? If your y is bigger than 3, my slope is each time, oh wait, bigger than 3, sorry, positive. When y is positive, oh, wait a minute, why is this not making sense in my brain right now? Oh, okay. Because here we would have, what was this slope? That was positive 3, right? Positive 3, positive 2, positive 1, 0. What do we have here? 1/2. Excuse me. Negative 1/2, negative 1/3, or 2/3, and then negative 1. Now do you see it? My brain was taking a moment to get there. Those values all just decreased. Because we went positive to 0 and then 0 to negative. What are we going to do down here? We start with negative
To 0.
and then go positive. Okay, that's what I was trying to get you to see. I was just struggling there. So I have it written, if y is greater than 0, then dy dx decreases. I think I also kind of forgot from what we were referring to that graph. If y instead is greater than, I reversed those, didn't I? Dang it. Don't try and hurry, Amy. Don't. Nice. If y is, which one was this? Greater than 0, then dy dx decreases. If y is less than 0, then dy dx increases as you move left to right. Okay. I can remind me we need to fill in H tomorrow. Hopefully my big Q will cooperate and not erase overnight. And then we'll do some matching. We'll draw another one. I almost hate to say this out loud. Maybe work time tomorrow? I don't know. Anytime I say that out loud, it backfires on me. So